In this example, we're going to see how we can use queues to keep track of a secret key that allows us to encrypt and decrypt a string. So before we talk about the actual code, let's take a look at what we're trying to do here. So you may have seen this very simple encryption scheme where you take each letter and then you add some amount to it. You shift it by some number. So here our key on the left, our key is 1. So we'll say H when we add 1 becomes I, E when we add 1 becomes F, L when we add 1 becomes M, we have another M, and then O when we add 1 becomes P. So this is a really straightforward encryption scheme that's not very good. First off, because you only have 26 possibilities, let's say, or actually I guess since you have however many there are numbers available in the character type, but it's still not a whole lot, and a computer could track this down very quickly. In fact, applying some well-known statistics, you could actually analyze the string if it's long enough and pretty much guess what the shift would be. Now this shift could be more than 1. I'm just using these small numbers here just so that it's easy to see the difference that the key makes. So we can enhance this by using more than one key. So here our key is not just one number, it's actually an array of numbers. And what we do is we shift the first by 3, the next by -1, the next by 2, then we start over at the beginning of the key. So we use 3, -1, and 2 for H, E, and L to give us K, D, and N. And then we start over with 3 on L, and we shift the O by -1. And you'll notice letters that are the same in our encrypted key now are different, and letters that are the same in our encrypted string are actually mapped to different characters in our original string. So this is a really simple technique, and this would still not go over very well if you really needed to keep a secret. It can still be broken, but it's a lot tougher to break than just the simple key system here on the left. So let's see how we would do this in code. And I'm not going to try to make this a full-fledged application. Obviously, you don't want to do encryption and decryption as in loops in your main method. It doesn't really help if you, hey, I'm going to encrypt it and decrypt it. Obviously, you would create some type of system that took in a string and returned the encrypted string, and then you would write another method that took an encrypted string and took a decrypted string. And we'll leave it up to you and your partners in crime to figure out how to pass the key back and forth. So here we have an integer array, and we have 6 values in this key. So this is longer than the other. And of course, the longer this is, the better. And we'll use this integer here to pull off one key value from this key each time we decode a character. And then we have 2 empty strings, one for our encoded string and one for our decoded string. So our original message is going to be this string: computer science is no more about computers than astronomy is about telescopes. I believe that was Etzker Dijkstra who said that. And then I'm going to create 2 queues, one for encoding and one for decoding. I'm going to put my key into each of these queues. Now these need to be the same, and I need to have 2 different ones, because as I modify this queue, the way I'm going to do this is I'm going to take a key value off the front of the key queue, use it, and then I'm going to enqueue it again. And remember, since this is a queue, it's going to go back to the rear of the queue. And hopefully you understand why we're using a queue here and not a stack. If we used a stack, it would essentially be this algorithm, because we would take this off, use it, put it back on, and next time around we use the last one we added if it's a stack. But since it's a queue, this will treat this as almost like it's a circular array. Back to our code, we'll print out what the original message is. Then we're going to load up the 2 key queues. And you can see we scan through that array, and for each value in the array, we enqueue that value into both the encoding queue and the decoding queue. Again, they have to be the same. And now we encode the message. We go through the message, and notice this will be a for loop that starts at index 0 and ends at the last index in the string. We get that key value by dequeuing something off the queue. Then we encode the message by adding a character, and that character is going to be whatever character is at that index of the original message. We add the key value to it, and since characters are a numeric type, we can actually add a numeric value to them, and then that will give us whatever character is that many characters past the original character. And then we enqueue back the key that we used. And again, by dequeuing, using it, and then enqueuing it, we'll guarantee that we don't run out of keys because we keep adding the ones we use to the rear. So this gives us our encoded message, which should be gibberish or pretty close to it. And then to decode it, notice we're going to do the exact same thing. We're going to take a key off now the decoding queue. We're going to add to our decoded message the character that we get when we pull the character at each index off the string. We subtract the key value now, and then we re-encode that key. And once we're done, we have a decoded message. So if we run this code, we can see we have our original message, we have our encoded message, which is sufficiently gibberish, and then our decoded message is the original message. And again, this is the actual encoded message. We're not just reprinting that message, that original message. We were able to get the decoded message by using this string as an input. And if you wanted to make this into an actual application, you could sort of see how this would work. You would need some way of passing the keys between each other. But then once you did that, you could have a method that took, say, the encoding queue and the original message, and it would return the encoded message. And then you could have a decode method that took the decoding queue and returned the decoded message. And there's nothing magical about either of these messages. We could, if we wanted, encode again the message and so forth. But of course, we would just get further gibberish in that case. So this is an example of how queues can be used. And we'll see some more later. And I don't think I mentioned this at the beginning, but we are using the fast queue that we wrote because that gives us the queue methods. So we can use enqueue and dequeue on those queues.